So I'm going to go and show you how to solve these using the conversion factor method. Big idea is we already have found the molar masses, and from the table up here you can see the molar masses for the different substances and then the moles for the different substances. So I'm going to keep that same table up there that you use for the for every statements. My starting point here is going to be 270 grams Mg3P2. Then I'm going to use my conversion factor for Mg3P2, and my conversion factor is basically right here. Grams has to go on the bottom to cancel with grams on top, so Mg3P2, okay, is 135 grams for every 1 mole of Mg3P2. So that is my first step in the process. I cancel out grams of Mg3P2 and I have moles of Mg3P2. Now I'm going to do a mole to mole step. So moles of Mg3P2, cancel those up here, and I'm going to moles of FeP. So now I'm going to use this comparison here, where I have 1 mole of Mg3P2 and 2 moles of FeP. Moles of Mg3P2, moles of Mg3P2 cancel out. I take 270 times 2, divide by 135, and I'm going to get theirs as 4 moles of FeP. Is how I'm going to solve that. So that's how I've solved this using the conversion factors. So for the next one, do the next one in blue here. For the next one, same starting point, and it's going to be the same first step. In fact, it's going to be the same first few steps. So I take 135 grams of Mg3P2 to 1 mole of Mg3P2. Coming from up here, grams of Mg3P2 cancel out. Now I go moles of Mg3P2 to moles of FeP. That comes 2 moles of FeP, 1 mole of Mg3P2. Those cancel out. Now it says how many grams of FeP. So now I'm going to go mole of FeP on the bottom. Oops, let me get that there. Mole of FeP on the bottom and gram of FeP on top. So now I have my choice. I can either use, there's 2 moles for every 174 grams, or you could do this as there's 87 grams for 1 mole. Molar mass is always for 1 mole. So if you just use the straight molar mass from the periodic table, it's going to be a 1 and it's going to be 87. If you're going to use this table, you may have, you figured out you doubled, that's why this is times 2 here, you doubled this, so you would do 2 for every 174, which if you just reduced it, it would reduce down to your 87 grams. So when you multiply 270 times 2 times 174, divide by 135 and divide by 2, in the end, your answer is going to be 348 grams of FeP. So that is how you're going to go about solving that. Next one says 1,111 grams of MgNO3 And so I find the molar mass of MgNO3 or I can look up here, we found it's 148 grams of MgNO3 for every 1 mole of MgNO3. You might be like, what? Why did you do that? I did this because this is the molar mass of one of those. So I did this as it's for every one. You could just as easily say 444 for every 3 and put 444 on the bottom and 3 on the top. Numerically, it'll work out exactly the same. Then to cancel, moles of MgNO3, 2 goes on the bottom, and moles of FeNO3, 3 goes on the top. This is a 2, and this is a 3. Moles and moles cancel. And so then in the end, when I multiply and divide, I'm going to get an answer here of 5 moles of FeNO3. So the last problem I'm going to do is here, grams of MgNO3. Then I use the molar mass of this. The molar mass of MgNO3 is there's 148 grams. You know what? Actually, I'll do this one. I'll say there's 444 grams of MgNO3, 2 for every 3 moles MgNO3, 2. Again, these two steps here are identical, but here I just used it for 3 moles, and if I take 444 divided by 3, I'll get the 148. Then I'm going to go 3 moles of MgNO3, 2 for every 2 moles of FeNO3, 3. Again, I'm going this here to this here. And then my last step is for every 1 mole of FeNO3, 3, there are, and for 1 mole, I'm going to use the 242 grams of FeNO3, 3. So when I multiply across the top, divide by stuff on the bottom, I get an answer. I'll write it over here in red of 1211 grams of FeNO3, 3. So that's how I would go about solving these problems using conversion factors.